Hello, my name is Corey Padilla, and I'm here from Dovetail Genomics to talk to you about how we've been trying to redefine the Hi-C toolbox for epigenetic and conformation applications by generating the highest resolution contact matrices possible through the use of MNase, as well as looking at the protein-directed chromatin architecture with our new high-chip kit. So to start, I'd like to orientate you to our new Micro-C kit, which is basically an MNase-based approach to Hi-C. So instead of using restriction enzymes, we use the micrococcal nuclease to cut between nucleosomes and to chew back, so we're getting a 146 base pair fragment that's distributed frequently across the genome as opposed to making more random cuts or having fragments that are of random sizes. What this enables us to do is to phase nucleosomes during a Hi-C reaction. So if you look at the image on the left, what you see is a metagene analysis of the average coverage across many CTCF sites between Micro-C and restriction enzyme-based approaches to Hi-C. Now, if you look at the blue line, which is the Micro-C data, you see this oscillating pattern as you move away from a CTCF site. The peaks in this oscillation are DNA that's protected by the nucleosome, while valleys are linker DNA that's chewed away during the MNase digestion. Now, if you were to plot this out on a genomic region, which we've done here on the right, you'll see that the Micro-C coverage shows peaks at about every 146 bases, which allows you to look at the nucleosome remodeling, meaning have nucleosomes been shifted, have they been chewed away, or are they uniformly positioned? Something that is currently not possible with restriction enzyme approaches. Now, if we were to take this image on the left and turn that into a contact matrix, which is what we've done here. So you're looking at two contact matrices, one on the left being generated from Micro-C data, the one on the right generated from multi-restriction enzyme Hi-C data. And as you can see, there are differences in between these two matrices because in the one on the left, the Micro-C data, you can see where these nucleosomes are positioned, but moreover, as you move away from the diagonal, you can see how these nucleosomes are interacting with each other. So with the Micro-C data, you can zoom in even past a looping event to look at how mono-nucleosomes interact, which is just something that you can't do with restriction enzyme-based Hi-C. So what's really cool here is if you combine the MNase-based approach to Hi-C with an immunoprecipitation post-fragmentation, you get our Dovetail high-chip kit. And this allows you to look at the protein-directed chromatin conformation. So we've done that here with CTCF. So we're comparing normal ChIP-seq data, which is the top blue line, with high chip data, again, pulling down on CTCF. And as you can see, the peaks between both of these tracks line up very nicely. But additionally, with the high chip data, you get the chromatin conformation, or how these regions of DNA are interacting with each other, by looking at the contact frequencies, which are represented here by the arcs at the bottom. Now, if you were to zoom in on one of those peaks, as you see below, you get the nucleosome positioning that's inherent to our Micro-C data that currently isn't being captured with today's ChIP-seq. So with that, I'd like to leave this image up and say thank you for listening. And if you have any questions, please reach out to us. We're more than happy to answer any of them. Thank you.